hopefully just a thumbs up, everybody can see my presentation. Okay, good. All right, make sure that we're up and running there. So I just wanted to maybe start with a few comments about maybe what I'm up to with this presentation. So I would like for everyone to kind of think of this as a kind of transition to our conference over the next few days, really kind of querying questions of risk, resilience, and adaptation, and also past to present or past to present and future connections that this project is trying to make. Here, I would say that the focus is a little bit more on traditional archival methodologies and how they might interface with a digital humanities project like Appraising Risk. And this is both an attempt to make those connections, but also kind of a plea for help. I'd really like to hear from you guys how you think we could incorporate this kind of material. One of the frustrations or challenges, I think, with this project has been, as a Middle East specialist who works with Ottoman sources, Arabic sources, but also colonial sources, is trying to figure out this sort of interoperability of those non-colonial sources. How do we incorporate that data? I think it's a little bit harder to sort of move that data around as opposed to some of the colonial materials. So I think that's kind of an open question for everyone. Also, how can we mix new digital tools with older tools like oral histories or colonial archival sources that may be appearing in a sort of newer, updated digital formats? I think one example that I'd like to sort of draw your attention to is a question kind of drawing a comparison. Both Dr. Gooding and myself were talking about water, but in very different ways. So would the methods described in Dr. Gooding's presentation have equal applicability to the Arabian Peninsula or the Persian Gulf, where rainfall was always scarce? And 20th century solutions to these problems have resulted in a dramatic reconfiguration of the availability of water, allowing previously unthinkable demographic development. In other words, what kinds of archival categories can we use to document a category like water beyond measuring rainfall, floods, or famine? In other words, how do we bring in some of the technical, techno-scientific, enviro-technical questions that this presentation brings? I've also been thinking a good deal about how environmental histories in recent years have been thinking through climate, but many times as parallel parables about climate change, documenting weather or natural disasters in the past without always firmly connecting them to the present. However, this talk and accompanying workshop materials are an attempt to get us to think through an environment like the Arabian Peninsula that is an enviro-technical creation, co-evolving alongside the fossil fuel altered world that we now call the Anthropocene. In other words, here the emphasis is on human and technological responses connecting the past and present and future. Likewise, how do we think about questions like adaptation, risk, and resilience in Arabian societies that have radically transformed from quote unquote traditional and Bedouin to some combination of westernized, transnational, and fossil fuel centric? How might this question give us a really sort of new tools in this past to present modeling at the heart of this project? And moving to the Middle East, how do we think about what counts as indigenous responses to climate challenges and climate change? Is this a different question moving from, say, the Persian Gulf to African or South Asian or Southeast Asian contexts? I'm very curious to sort of see where we fall on that question. I very much look forward to hearing your thoughts on how we can integrate these questions into the Appraising Risk project, especially as we look to put together an edited volume out of our conference proceedings this week. And just looking ahead to the coming days, we're really looking forward to having Professor Debjani Bhattacharya give our keynote, and also she's agreed, if we were able to pull together a volume, to do a sort of an afterword for that book project. So kind of keep that in mind as we go along today as well. Okay, so what I want to start with is a kind of, I'm kind of calling this idea Indian Ocean ghosts of steam reincarnated in the age of oil. So paradoxically, the history of desalination begins not with water, but with energy history. The emergence of desalination technology has a long and complicated history in the Middle East. While desalination would ultimately become one of the most important manifestations of oil-driven modernization, the rise of desalination technology in the Arabian Peninsula actually predates both American involvement in the region and the discovery of petroleum and the astonishing wealth that it generated. Indeed, the first era of desalination, that is, converting seawater into fresh water in Arabia, emerged at the confluence of the late 19th century imperial infrastructures of coal and steam. From the 1850s through the first half of the 20th century, these earlier coal-fired experiments with desalination placed the peninsula in a unique position to capitalize on desalination's Anglo-American-led reincarnation between the 1950s and 1970s. A second coming fueled by oil companies, atomic ambitions, and the strategic interests of the Cold War. Now, here, as On Barak has recently argued, a ghost is haunting the field of energy studies and energy history, the specter of energy itself. What Barak points to is the tendency to misunderstand the energy regimes and energy transitions that give rise to particular kinds of societies. An energy regime is a collection of arrangements whereby energy is harvested from the sun, or perhaps from uranium atoms, directed, stored, bought, sold, used for work, or wasted, and ultimately dissipated. This basic formula seems deceptively simple. The windmill and the water wheel produced a kind of society of feudal lords. Coal and steam produced the industrial capitalists of England, and oil gave rise to the petrostates of the Arabian Peninsula. While there is certainly truth in this idea, as Barak warns, it overlooks the ways in which energy transitions do not always produce total ruptures. More often than not, the technologies of older energy regimes form part of the basic infrastructures needed to build up a new energy system and shift from one regime to another. Now, in this case, desalination, a key feature of the petro kingdoms of the 20th and 21st century Middle East, were first deployed in the region as an infrastructure of coal and steam. In this sense, rather than understanding the adoption of fossil-fueled desalination or man-made water technologies solely as products of oil wealth or Cold War futurism, in reality, it represents a lingering ghost of steamship and imperial transportation. Desalination served as a kind of midwife to the nascent petroleum-based states of the region, became deeply embedded in these societies, and has survived long after the original energy regime that it had been engineered to service passed away. Now, the region that we now know as the Middle East partially owes its middleness, let's say, when we think of the term Middle East, to the carbon storage networks designed to fuel the age of steam. In the late 19th century, the British Empire depended on the even spacing of coaling stations spread across the Red Sea and the Persian Gulf to service the increasing flows of steamship traffic moving between India, the Mediterranean, and England itself. Now, while coal is the obvious centerpiece of this transportation story, water, on the other hand, has remained a neglected part of this history. Advances in desalination methods went hand in hand with the rise of ocean-going steamships. The first steamers, originally used for river navigation, could supply their boilers with fresh water from the river around them. When ocean-going steamships were built, however, they encountered new technical challenges. Crews had to either carry freshwater supplies with them, or they would use seawater to operate ships' boilers. However, the use of salt water resulted in the accumulation of saline scales on the flues and bottoms of the ship's boilers. In addition to reducing the lifespan of iron boilers, salt water required more fuel to heat, yielded an inferior steam power, and increased the risk of boiler explosions. In order to overcome these problems, between the 1830s and 1860s, the development of surface condensers and seawater evaporators would eventually make it possible for crews to convert salt water into fresh water for both the ship's boiler and for the crew's consumption. As a result, the condenser became a kind of standard part of steamships. Now here in this slide, in addition to showing you On Barak's book here, Powering Empire, we've got a couple of postcards from what is present-day Yemen, the port of Aden, Steamer Point. Now, As Onbarak makes clear, the condenser did not remain stranded at sea. Over time, condensers also made their way to the ports of the Middle East, places like Steamer Point and Aden. From as early as the late 1850s and 1860s, the British Empire began to experiment with the installation of coal-fired condenser units in Eastern Mediterranean and Red Sea ports like Malta, Suez, and Aden, where local water supplies were unable to keep up with the new demands of industrial steamship traffic and the increasing numbers of foreigners settling in arid colonial outposts. In the 1860s, several condensers were deployed in Aden by the British Indian government, as well as by private companies like the Peninsular and Oriental and Messrs. Luck, Thomas and Company. While these companies primarily served their own ships calling at port, under normal conditions, both government and private condensers sold water to the general public. However, in times of drought or emergency water shortages, these units could be called upon to sustain the Raj's foreign population, which by the mid-1870s was a little over 9,000 people, calculated to consume some 5 gallons per day, right? So here we've got an additional variable, right? It's not just how much rainfall or groundwater there is in one of these arid places. It's also the changing dynamics of the technologies surrounding coal and steam and industrialization. Now, in the 1880s and 1890s, lengthy military engagements in places like Egypt and Sudan also tested Britain's ability to supply water to its troops. At first, steamers were kept in ports like Suez and Suakin solely to generate fresh water from their boilers, right? So you might have, as in this situation, soldiers who are moving inland in arid places and encountering unsafe drinking water. It may be contaminated by, say, a dead animal in this case, or perhaps cholera outbreaks in the region. So they needed some sort of reliable, mobile way to supply fresh water to their supply lines. Now, over time, these kinds of emergency security operations became normalized as permanent features of the region's water infrastructure, leading to the installation of land-based systems with larger and larger capacities. Thus, by World War I, these British condensers formed a kind of desalinated archipelago from Suez, Port Said, Sudan, Suakin, Param Island off the coast of Yemen, and Aden in the Red Sea to places like Muscat, Bahrain, Kuwait, Bushehr, and Kerman in the Persian Gulf. We could think of this kind of archipelago stretching all the way around the Red Sea and the Persian Gulf as a kind of necessary infrastructure, just as necessary as coaling stations to connect Britain's empire in the Eastern Mediterranean with its most prized possessions in the Indian Ocean, most notably in South Asia. Okay, so you may be asking yourself, how on earth did I come to think about this question? Well, I started my career really, I sort of think of one of the sort of moments on this island, this desert rock off the coast of Yemen, Cameron Island. And I was researching for what became my first book about quarantine stations designed to stop outbreaks of cholera from spreading from India to Mecca on the pilgrimage, the Hajj, right? And eventually, this question of provisioning along the Red Sea and the Indian Ocean and questions of water safety and security brought me into contact with some of the earliest experiments with desalination technology. So I actually went into the archive hoping to find things about cholera and quarantine, but increasingly when I got into the Ottoman archive in Istanbul, I found lots and lots of material about water infrastructure, about water carriers, about broken aqueducts, insufficient supplies to keep up again with the industrialization of the steamship era. And ultimately, in this document in the bottom right-hand side of your screen, I found the first reference in the Ottoman archive in the 1890s, 1894 actually, to a request to purchase a tugboat equipped with a desalination machine. And they basically wanted to copy what was being done in places like Egypt and Sudan by the British in order to sort of provide a lifeline for the Hijaz and pilgrims in that region. Now, I could hardly kind of believe my eyes. I wasn't expecting to see that kind of technology, a technology that, to be frank, I expected to see in 1970s or 80s Saudi Arabia, but not in 1890s Ottoman Arabia. So sort of fast forwarding, just before World War I, the Ottoman state and the Glasgow-based Mirrlees-Watson company built Jeddah's first desalination plant. And coincidentally, there's a sort of interesting story behind Mirrlees-Watson too. That's a great history of capitalism that I wish someone would tell. Really, the methodologies for creating desalination machines came from sugar plantation processing. So Mirrlees-Watson, their primary business for many, many decades had been supplying machinery to the Caribbean to process sugarcane. But they pivoted in the 20th century, late 19th and early 20th century, to do desalination machines and condensers. So this plant that you see, this machine on the right-hand side of your screen, was a tremendous technical achievement for the Ottoman Empire, but it turned out to be a kind of fleeting victory in the long Ottoman struggle with both drought and cholera. Just 5 years later, less than 5 years later, Ottoman rule in the region was ultimately swept away by the British-backed Arab Revolt of 1916 in World War I. The Jeddah plant provided a kind of temporary lifeline, though, to the successor Hashemite and Saudi kingdoms that filled the void left by the Ottoman state in the wake of World War I. Indeed, it provided a kind of miniature model of the future, a blueprint for re-engineering the entire peninsula's water supply to meet the demands of petroleum fuel development that emerged in the coming decades. I love this poem. As I sort of narrate, I encourage you to sort of read this sort of local poem complaining about the advent of man-made water. When the Saudis conquered the short-lived Hashemite kingdom of the Hijaz in 1925, they inherited the Hajj's chronic water problems. But by then, the condenser facility completed by the Ottomans by 1914 and taken over by British engineers during World War I had become an essential part of daily life and survival for locals in the port city of Jeddah and international pilgrims alike. The Ottoman plant had become known to locals as Al-Kandasa, the Arabic corruption of the condenser. Although the supply of distilled water was, of course, expensive, barely palatable, notoriously unreliable, and made up only a fraction of Jeddah's supply, it provided an indispensable safety net, supplementing Jeddah's unreliable rain and groundwater supplies. Now, recognizing the impact of the Ottoman condenser in 1926 and 1928, King Abdulaziz ibn Saud imported 2 new submerged tube seawater desalination machines in an attempt to keep pace with Jeddah's rising water demands. Thus, even before the arrival of American oil interests and the discovery of commercial quantities of oil in Saudi Arabia in the 1930s, the Anglo-Ottoman infrastructures of Indian Ocean coal, steam, and pilgrimage had already demonstrated that the era of carbon-fueled or sort of fossil-fueled saltwater extraction was well underway. So this led me on a kind of chase to find figures to sort of merge my Ottoman source base with colonial materials, but then local materials in Gulf states, Saudi Arabia, the United Arab Emirates, Kuwait, etc. And one of my favorite characters in this story is a man named Mohammed bin Faisal, or Mohammed al-Faisal, who was the second son of King Faisal of Saudi Arabia, who was ultimately, King Faisal was assassinated in 1975. But Prince Faisal was destined to become what I've come to call Saudi Arabia's water prince. And he has quite the colorful career that I'm going to be showing you some sources. One of the groups is going to be working with one of my favorite bits of archival discovery. So group 3 is ultimately going to be working with material related to special collections that are found at Iowa State University, my previous home institution. And strangely enough, there was a conference about towing icebergs from Antarctica to Saudi Arabia that was held at Iowa State in 1977. Now, before you say that's completely crazy, this certainly captured the imagination of really serious scientists during the Cold War. And I think what's interesting about this is Mohammed bin Faisal was really sort of searching for an alternative to desalination technology because he was really worried that it was going to be too energy intensive and too expensive. But this is a really interesting question about sort of 1960s and 70s sort of Cold War era geoengineering schemes and how that might relate to some of our present climate change predicaments. Now, while Al-Faisal has often been mocked for his ill-fated schemes to tow icebergs from Antarctica to the Red Sea or to build water pipelines from Turkey, some of his aquatic dreams actually did come true. Between 1963 and 1976, he would build the foundations of what would grow into the world's leading producer of desalinated water. As Al-Faisal recounted in a 2015 interview, his first interest in desalination was sparked as a child drinking condenser water from Jeddah's Al-Qandasa plant, which was in the previous slide. 2 decades later, while studying at Menlo College near San Francisco, the prince would find himself at the epicenter of America's a burgeoning turn towards desalination technology. During his studies, Al-Faisal visited a multi-stage flash desalination unit built by Aquachem, which was at the time a subsidiary of Coca-Cola, for Southern California Edison's Ventura power plant. Impressed by the advances being made in California and the US, he was armed with the idea that would ultimately become his most important legacy. Now, just a sort of note about this idea about towing icebergs actually hasn't gone away. This guy, Abdullah Ashehi, who is a UAE national working at a green think tank called Mustar City, actually has resurrected in the last 5 years this idea and is sort of shopping this alongside a variety of other cloud seeding, weather modification, geoengineering projects for the UAE. And so again, all of this, sort of zany thinking on the part of Mohammed bin Faisal, it's not so different than the kinds of things that someone like Bill Gates is pushing, pumping aerosols into the atmosphere to deflect heat. So I want us to kind of think about the sort of grandiosity and pomposity of some of these kinds of projects that flow out of this history of man-made water making. So Al-Faisal, he ultimately was successful in bringing desalination, large-scale desalination to Saudi Arabia. Here we have a 1964 drawing that was done by the United States Department of the Interior and the Office of Saline Water and helped along by the State Department. Ultimately, this plant was built in 1970 and became the cornerstone of what would become the Saline Water Conversion Corporation in Saudi Arabia, which now produces by some estimates, 60% of global capacity of desalinated water. So the world's leading producer of desalinated water. And if we think about the Arabian Peninsula as a whole, we're approaching roughly 3/4 of the world's production of desalinated water happens in the peninsula. Now, another example of the arrival of desalination comes on the other side of the peninsula, a similar kind of symbiotic relationship between empire, hydraulic expertise, and fossil fuels was unfolding in Kuwait. In 1909, after an especially dry winter, local merchants began importing fresh water from the Shatt al-Arab in Iraq to sell to Kuwait City's townspeople, rather than depending on rainwater and the surrounding area's brackish wells. In an attempt to break Kuwait's dangerous dependency on water imported from Iraq, the Emir, Mubarak al-Sabah, commissioned the Anglo-Persian Oil Company, which eventually becomes BP, or British Petroleum, to build a condenser plant, which opened in 1919. Although the plant closed in 1924 due to a string of technical difficulties, this was a harbinger of things to come. Between 1924 and the 1950s, Kuwait was forced to continue importing fresh water by the boatload from Iraq. In the early 1950s, Kuwait contemplated the construction of a water pipeline to import water from Iraq. However, in 1956, the idea was ultimately discarded, and Kuwait once again turned its full attention to large-scale desalination. Immediately after World War II, Kuwait's oil industry was already edging the country back toward experiments with desalination. In 1946, the Kuwait Oil Company installed a plant which was essentially built around a salvaged evaporator from a World War I era destroyer. This makeshift unit was operated intermittently until the 1950s, when the Kuwait Oil Company purchased their first commercial unit, one of the first 1 million gallon per day submerged tube seawater desalination plants in the world. The new plant yielded its first water in 1953, and over the course of the 1950s and 60s, Kuwait began to build more plants and switch from older, less efficient techniques to newer multi-stage flash technologies being pioneered in the United States by Westinghouse. By 1966, Kuwait had temporarily become the world's leading producer of desalinated water, reaching a capacity of over 13 million gallons per day at a cost of roughly $3 per 1,000 gallons. Now, Kuwait's bullish embrace of desalination technology was illustrative of intimate, even symbiotic relationships emerging between oil and water. When American oil men, geologists, and engineers descended on Saudi Arabia and the rest of the peninsula from the 1930s onward, but particularly after World War II, they encountered kings, emirs, and princes eager not just to develop their nation's petroleum resources, but also to secure water supplies sufficient to support their dreams of economic growth and modernization. As Dr. A.L. Miller, director of the U.S. Office of Saline Water, observed, Kuwait's early success offered what would become a template for desalination and what it might produce in terms of economic growth beyond water. Addressing a meeting of petroleum refining professionals in 1959, Miller held up Kuwait as the key to understanding desalination's potential for the oil industry. Here we see some of the test plants and some of the experimentation done by the US Office of Saline Water. As Miller points out, desalination and drilling for oil were natural allies. On the one hand, the oil industry's enormous water requirements for both drilling and refining operations had already made it the leading consumer of desalinated water. From desalination's use in oil refining operations on the parched Caribbean island of Aruba to seawater conversion for American offshore drilling, Miller envisioned replicating the symbiotic relationship between desalination and oil production being forged in Kuwait and expanding it to domestic locations in the US like California and Texas. Although ominous from the vantage point of the Anthropocene is today's struggle with global climate change, Miller also puts forward a prescient view of how desalination would also drive forward increased energy demand and profit. One thing is clear, the conversion of seawater to freshwater in quantities approaching only a few percent of the current water consumption rate will require expenditure of staggering amounts of energy, either as thermal energy for distillation or mechanical energy for pumping. The energy requirements are so large indeed that as we come to rely more and more on converted seawater and brackish water to augment our supplies of natural fresh water, a great new market for fossil fuels, oil, will develop. From Miller's perspective, building up interest among oil industry professionals held the potential to speed up the pace of desalination research and development, while simultaneously stimulating even more demand for oil. At the same time, however, Miller's enthusiasm for this water energy nexus points to the fundamental problem haunting desalination operations even today. Desalination has always been a creature of carbon, originally a child of coal and steam, but maturing into a global force in the age of oil. It has profoundly shaped it has been profoundly shaped by the costs and ease of access to energy. Energy, as much as saline water itself, remains the key ingredient in the production of desalinated fresh water, a process that I've, in a few articles called a kind of black magic, the alchemy of turning oil into water. So I want to show you a few possibilities of the kinds of sources that we could use for this. So some of the sources that you see on the screen here, in particular this book, Between Sips of Coffee, is a translation of an Arabic collection of oral histories of basically life in the United Arab Emirates before the advent of oil in the 1960s. So one of the things that I'm hoping to do with sources like this is tell a kind of bottom-up story of how people in the Arabian Peninsula experience the transition from traditional water methods, wells, aqueducts, filage systems, to man-made, industrialized, fossil-fueled water, and what that looks like for people on the ground. So I'm going to talk a little bit, and in some of your breakout sessions, we're going to look at an area between the capital city of the United Arab Emirates, Abu Dhabi, and a place called Alain on the border with present-day Oman. So here, in breakout group number 1, you guys are going to read in particular from this woman on the top left-hand side of your screen, Hamda bint al-Hamid al-Hamili. And I'll sort of give a little bit of context here. While the meteoric growth of Abu Dhabi from a little more than a coastal village to a global capital is undoubtedly a product of the seemingly magical effects of oil wealth, the city is also a product of a somewhat forgotten source of water, both human and infrastructural. As Hamda bint Hamid al-Hamili recalls, in the hard but sweet days before oil, Abu Dhabi's very existence was made possible by its precarious supply of palatable drinking water. For decades, the men and women of Abu Dhabi had survived on water obtained from digging shallow wells or pits in the sand. The water that it yielded was brackish and barely life-sustaining, and worse still, these temporary wells might only last a few days before the salinity rendered the liquid at the bottom fit only for animal consumption and eventually only for washing. In turn, this meant that new pits would have to be dug to acquire fresh water supplies almost constantly. While this meager supply might have been enough to sustain the seasonal rhythms of pearling and the 5,000 or so inhabitants of the town of Abu Dhabi in the early 1950s, with the discovery of oil by the early 1960s, the burgeoning oil city's tenuous water supplies would begin to strain under the weight of its new increasing labor force and rising population. Just for a sort of sense of the dramatic nature of changes, if you have a population in the 1950s in the town of Abu Dhabi of 5,000, today the same city is roughly 1.4 million in the city limits. So just, you know, unfathomable change in a span of less than 75 years. So here, our first breakout group will read from Hamda bint Hamid al-Hamili's recollections of women's role in the production of water during this period. As you will see, al-Hamili's recollections of the pre-oil era also bring into sharper focus the degree to which Abu Dhabi's water insecurity defined its position between the pearling and fishing of the Gulf and the relative hydraulic and agricultural abundance of the date farms and oases clustered around the mountain town of Al-Ain in the United Arab Emirates and its conjoined sister town, Buraimi, in the Sultanate of Oman. Thus, after the dhows, the pearling vessels left Abu Dhabi for the dry summer months, the wives and families of the pearl divers and sailors would depart for Al-Ain or the Liwa Oasis, leaving Abu Dhabi with a population of essentially a skeleton crew of non-Arab merchants. So this was a kind of fundamental problem for these societies, how to adapt their traditional water infrastructures for the coming of industrialized fossil fuel production. As the seasonal nature of pre-oil Abu Dhabi's limited hydraulic capacity makes clear, like the caravans and pearling ventures, the emerging city remained deeply dependent on the oasis and agricultural output fed and nurtured by underground fresh water located at the foot of Jebel Hafid and the Hajar Mountains near Al-Ain. The mountain waters tapped by the underground Aflaj channels. So when I talk about Aflaj, on the right hand of your screen here, you'll see what are essentially, in Persia, you would call them qanats, but these are Aflaj, an irrigation system, bringing fresh water from the mountains and distributing it from an oasis to points further afield. Now, the mountain waters tapped by the underground Aflaj channels and nearby wells sunk into the water table represented a kind of umbilical cord that sheltered and nourished coastal Abu Dhabi before and even after the arrival of commercially viable oil resources. Indeed, even after the first desalination unit arrived during the reign of Sheikh Shakbut, pictured on the bottom left-hand side of the screen, in 1962, Abu Dhabi would remain really dependent on the distribution of water via donkey-borne oil cans. So you see the donkeys on the bottom left-hand side of your screen here. Those cans of water cost roughly a dirham. At the time, crude oil cost just 70% of what a can of water borne by a donkey would. Now, the question that I want to answer is, how did local people experience the dramatic transition from wells, oases, and falaj to piped water, electricity, and massive desalination facilities that came in to being under the reign of Sheikh Zayed and the construction of wells and piped water from the Al-Ain Oasis? But today, of course, all of the regions of the United Arab Emirates rely on desalinated water piped from coastal towns and desalination facilities. So to describe this journey, I see this as a kind of absolute reversal of the normal flow of history and ecology in the region. So if we look at this map, the mountain regions near the coast, or not the coast, the border of Oman, near Al Ain, those used to be the sort of most important breadbasket and water source. But now, today, water flows in from the coast via desalination. And thus, really, the sort of traditional structures and normal ecology of the region has been turned completely upside down. Okay, I want to conclude with a kind of conundrum as you look at these primary sources. So over the past really 2 years, in the midst of a kind of greenwashed public relations blitz for Expo 2020 in Dubai, the United Arab Emirates announced their intention to reach net zero carbon emissions by 2050. Now here, I won't quibble with how realistic their plan actually is. I don't think it is particularly realistic because they intend to continue to pump oil hand over fist and make money. Rather, I just want to conclude by noting a kind of entangled relationship between desalination and oil consumption, a kind of catch-22 for these societies in the era of climate change. Now, Saudi Arabia, the UAE, and their Gulf neighbors have all embraced fossil fuel solutions to address their acute water problems. Desalination has become a defining material feature of life on the Arabian Peninsula, arguably second only to oil. The Gulf's transition toward total dependency on desalination has ushered in an era from which there can be no escape. Since the 1970s, oil and water production have become inextricably linked. Not only have oil revenues subsidized impossibly low water prices and high levels of consumption for the Gulf states' subjects, oil itself has become the key ingredient in the manufacture of the peninsula's water. In 2010, Saudi desalination operations consumed a mind-boggling 1.5 million barrels of oil per day, representing something like 15% of the kingdom's daily oil production. So 15% of every barrel of oil produced in Saudi Arabia goes straight to making water. This energy-intensive solution depends on the basic conceit that oil production and wealth will be able to indefinitely keep pace with the development and demographic base that it's enabled. But unlike the black magic of turning crude oil into government revenue or private wealth, the production and consumption of desalinated water has fostered an even deeper material dependency. Through the techno-political alchemy of transforming oil into water, the monarchies of the Gulf have cast an unbreakable spell over their subjects. Mirroring the Arabian Peninsula's petroleum-based ethos of endless energy, the large-scale adoption of desalination technology has given rise to an equally problematic environmental imaginary of infinite water. With renewable water capacities of less than 500 cubic meters per capita, states like Saudi Arabia, Kuwait, and UAE suffer from absolute water scarcity. And yet, in their fossil-fueled hydro-imaginaries, renewable water resources have been rendered virtually obsolete. Non-renewable or non-conventional sources have allowed these states to imagine their water supplies as infinitely expandable. If there's no more rain or groundwater to be tapped, more can simply be extracted, processed, and produced. The potential for harvesting the sea has been decoupled from the realities of existence. Socio-technical procedures created to govern the flow of oil, conceptions of infinite desalinated water, have allowed the Arabian Peninsula to ignore and efface the natural limits of this critical resource. And here again, I want you to think about the difference between the worlds described in Dr. Gooding's sources versus the world that I'm describing here. Now, each day, dozens of the world's largest desalination plants pump some 70 cubic meters of super salty reject brine back into the waters of the Persian Gulf. As a result, the Gulf is now 25% saltier than normal seawater. With the Arabian Peninsula's groundwater sources decimated and climate change bringing ever higher temperatures, Gulf states are projected to nearly double their capacity for desalination by 2030. But unless something can be done to address the problem of brine disposal, the water will eventually become so saline that it will be too expensive to desalinate. In short, the kingdoms of the Gulf are headed not for peak oil, but for peak salt. Mirroring the theory of peak oil, the point at which the maximum rate of oil extraction might be reached, peak salt predicts a future when desalination becomes environmentally and economically unfeasible. Now, not so long ago, the prospect of peak oil seemed to be the greatest threat to economic stability in the Gulf and the world. Today, however, as the new realities of man-made climate change loom ever larger on the horizon, the fear of running out of oil is slowly being overtaken by the need to make climate adaptations to deal with the consequences of the carbon dioxide that humans have already pumped into the atmosphere. In this sense, the notion of peak salt and peak oil are not so different. Desalination has always been a child of fossil fuels. It's rooted in the same hubris and drive for infinite resources and economic development. And even if the dramatic energy transition, a dramatic energy transition can be made, I remain skeptical that the 20th century world built by fossil fuel desalination can make the transition fast enough to escape the global need to move away from fossil fuel consumption and the looming pressures of wet bulb temperatures poised to render parts of the Gulf and South Asia virtually uninhabitable by as early as 2050 to 2070. So I want to just pause for one moment before concluding and show you this heat map of South Asia and the Persian Gulf. And I think this is particularly important because of the intertwined labor relations between India, South Asia, and the Indian Ocean and the Persian Gulf. So if you visit a city like Abu Dhabi or Dubai, you're going to notice that about 80 to 90% of the population is not Arab. They're from places like India, Pakistan, Afghanistan, Sri Lanka, Thailand, Philippines, what have you. Thus, the two most impacted regions by wet bulb temperature change in the very, very near future, facing a kind of heat death scenario, are sort of intertwined. And thus, the production of fossil fuels and its continuation depends on labor from one of the most heat and climate change affected regions in the world. So we have this sort of perpetual catch-22. If you continue to pump oil and use this kind of a massive amount of energy to make desalinated water, you're going to continue to contribute to the problem of climate change. If you move away from fossil fuels, you won't have enough money, resources, and fuel to continue this 20th century fossil fueled system of water production. So we really see the Gulf in a kind of rock and a hard place position as we move deeper into the Anthropocene and the 21st century. So I'm going to stop the presentation here and flip over and share with you your tasks as groups. So I believe since we don't have huge numbers, we'll have groups 1, 2, and 3. And I've outlined for you in the breakout rooms, group 1 will look at pages 2 through 4 in the exercise. Group 2, pages 5 and 6, group 3, pages 7 and 8. The first exercise will be oral histories around water production in Abu Dhabi. The second exercise, I can scroll down to show you here. So group 1 is going to be looking at oral histories translated from Arabic to give us a sense of what life before desalination looked like. Group 2, you're going to be looking at the first desalination machine that was imported to Abu Dhabi. You have a short article to read, and then you're going to be looking and exploring a really fascinating set of tools, the Arabian Gulf Digital Archives. Abu Dhabi has spent a lot of time and energy basically digitizing British colonial documents and making them amazingly searchable. So I want you to be able to kind of play with some of the underlying primary sources in this narrative for your questions in group 2. And finally, group 3, we're going to visit our Saudi water prints and talk a little bit about the wild scheme to tow icebergs from Antarctica to Saudi Arabia, and think about how that history of geoengineering is related both to the advent of desalination in Arabia, but also bigger problems facing some of the solutions being proposed to solve climate change in the 21st century. All right, so I believe that Nod and Julie will help us break out into our various breakout rooms, and I'll be floating between those if you have questions. You have some video to watch, group 3, so just to cue you into that, you'll want to watch the video at the top here before you get started with your questions. And then we should have about 30 minutes for breakout and hopefully 15 to 30 minutes for discussion of some of these materials. All right. I'll stop sharing.